Honors Pre-Calculus, Day 41, solving trig equations. So notice this little nugget. Oops. Whoa. Notice this little nugget right here. For x greater than or equal to 0 and less than 2 pi. So we're limiting you to one trip around the circle. So back to those homework problems where it was the pi over 2 plus n pi plus 2 pi plus 2n pi, all that stuff, that's out. We're only going to be focusing on one trip around the circle. So when is sine of x equal to 0.6? Well, you could think about it this way as well. We could take a look at it as graphically. Now, first of all, we should be in radians. I'll go back another slide and explain why. But y equals the sine of x. What does that graph look like? We know what it looks like. So now what I want to know is, where is the graph equal to 0.6? Where is the output 0.6? Where are our y values 0.6? So let's take a little bit of a different zoom. How about a zoom trig? Okay, that's more like it. And here's where our 2 pi ends. So it goes up to 1. So 0.6 will be somewhere in there. So you can see there's going to be two answers. And it kind of makes some sense because as we go around the circle, everything's positive in the first quadrant, sine is positive in the second quadrant, tangent's positive in the third quadrant, and cosine's positive in the fourth quadrant. So each sine, cosine, and tangent, and the reciprocals too, but sine, cosine, and tangent, they each have their own quadrant where they're positive plus the first quadrant. So there should be two answers to every trig problem. Now, just like everything else in math, there's exceptions, but the general rule of thumb is two answers to each trig equation. So in this equation here, because the restrictions were given in radians, that's how I knew I had to be in radians. So now I'm saying the sine of an angle equals 0.6. So what I really want to know, what's the angle with a sine ratio of 0.6? Mathematically speaking, I want to know the inverse sine of 0.6. So this really does remind me a lot of our log work here. So what's the answer to that? I don't know. I'm going to need the calculator. So the inverse sine of 0.6. Only one answer, 0.6435. So x is approximately 6435. Okay, great. That's a radian answer. That is telling me an angle. It's 0.6435 radians. But that's only one answer. There's supposed to be a second answer. Your calculator will not give you two answers. It will only give you one. Why? Because of all that work we did with that cheating mathematician, that 15 minutes of confusion where we had to genetically modify the sine graph so it had an inverse function, all that craziness, so we could have an inverse. We cut off a lot of the graph. There's another value. So now it's up to you to figure out, okay, where is the other answer? Well, let's take a look. We have 0.6435. That's going to be less than 1.57. So if we go for the decimal versions of our radians, so that's going to be a first quadrant angle. So 0.64 radians. Where else is sine positive? It's also positive in the second quadrant. So a reference angle of 0.6435. What would be the angle? That takes me from our starting position to that terminal ray. Well, pi minus the 0.64. I'm going to use my stored values. Notice I hit second answer, and 2.4981. And those would be my two answers. Might be a slide that you need to go back and rewatch. All right, now degrees. Okay, so just like algebra, get rid of the 9. 3 cosine theta equals -2. Cosine of theta equals -2/3. Okay, so now the cosine of an angle is negative. All right, let's see what that looks like. I am now in degrees, so this will be a little bit annoying having to bounce back and forth. The inverse cosine of -2/3, and I get 131.81 degrees. Okay, again, if you need to write this down, how did I get that? I did the inverse cosine of -2/3. And now that's only one answer, so where's my second answer? So that is my angle there. That's not my reference angle. So what you have to do now is say, okay, cosine is also negative in the third quadrant. So ultimately, your job is to find that angle there. You need a third quadrant angle, and you have a couple different ways of getting it. So the most basic way is find the reference angle and then just use it. So the reference angle now is going to be 180 minus 131. .19. So that's 48.19. That's the reference angle, which means that's 48.19 right there. So to get that angle all the way around, I would need to do 180 plus that reference angle. So plus that previous answer. And I'm going to get 228.19. And now I have my two answers. All right, so again, if you need to write down where that came from. And the reference angle was 180 minus 131.81, which equals 48.19. Now, that's one way of doing this, and it's a fine way of doing it. To me, what I like about that is you can always easily find the reference angle and then add, subtract to 360, 180, whatever you need to do. But some people start to recognize patterns, and if we back this up, almost there. If we back this up, you can see that that angle there is symmetrical to that angle up top. And so another thing that we could do is we could just subtract that from 360. So we could do the entire circle minus this portion, and it's going to leave us with what we're looking for. So 360 minus that. And you're going to get that exact same answer. That only works for cosine. It only works for the cosine negative ratio. So do you want to memorize a special rule just for cosine negative? I don't know. I don't. But it's there if you want to do it. If that makes sense to you, you see that visually, oh yeah, I get that, then by all means use it. So, all right. Moving on. All right, so first thing that I would do is I would put a square root in myself, meaning the cotangent of theta is going to be plus or minus 2. All right, and now the next thing I'm going to do is I don't have cotangent in my calculator, so I am going to magically turn it to tangent. You can't just wave your magic wand and turn a cotangent into a tangent. It's the reciprocal of cotangent. So you need to take the reciprocal of 2 as well. And now that I have this, and back in radians, annoying, but it's the life we chose. Now the inverse tangent of 1/2. All right, so we get 0.4636. That's my first quadrant representative. The nice thing about plus or minuses is you don't have to worry about which quadrants because you need them all. So 0.4636. Oops, my calculator, my hand calculator, I'm in the wrong mode. So there's my reference angle. So I'm going to take pi minus that. I'm going to take pi plus that for my third quadrant representative. And I'm going to take 2 pi minus the reference angle. Get 5.8. 1, 9, 5. And there are my 4 answers. Okay, now this is a little bit confusing here. So let's try to stay with us. Now, one thing that I haven't really talked about a lot so far is that tangent is y over x, opposite over adjacent. In the coordinate plane, y over x, we knew that as slope. So rise over run, y over x. So there's some sort of a link here between tangent and slope. Now, let's just dive in here. So if we're looking for the angle of inclination, we're looking for that angle from the x-axis to a line. So standard position opening up can be obtuse, can be acute. So what we're telling you though, what we're telling you now is that the slope is equal to the tangent of the angle of inclination. And it should make some sense if I were to drop a perpendicular line here, that's a 35-degree angle. The tangent of that angle is y over x, opposite over adjacent. And the slope of that line would be the, you could use the slope formula, y2 minus y1 over x2 minus x1. And so what is that going to give you? The difference in the y's, the difference in the x's? It's going to give you the same as the tangent would be. The length of that over the length of that. So they are the same thing. That's why this works. If you're like, whoa, 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 too fast, I don't get that. Okay. So then for the time being, we're just going to have to know that the slope of any line is equal to the tangent of that angle of inclination. Okay. So what does that mean to us? That means to us we're going to give you a line and you have to find the slope. So I know what you guys are going to do. You're probably going to subtract the 2x, divide by 5. Or we could do negative a over b. I don't mean to scare you. I know you like your slope-intercept form. So the slope is equal to negative 2/5. All right. So what this new theorem says is the tangent of alpha is equal to the slope of the line. All right. So it equals negative 2/5. So now what we have to do is we have to figure out, okay, what's that angle? All right. And I think we went back to degrees just because we're trying to be annoying. Inverse tangent of, I believe it was negative 2/5. So we get negative 21.8 degrees. Okay, we haven't seen that yet today. Well, that's a little worrisome. So negative 21.8 degrees. Now remember, when we were dealing with tangent and sine with their inverses, the negatives were defined in the first and fourth quadrants, but we said it was from negative pi over 2 to pi over 2. That was the domain. So this is what your calculator is going to do. If we do an inverse sine of negative, it's going to give us a negative as well. So you now have to go into your knowledge and say, okay, negative 21.8. What does that mean? That means fourth quadrant down here. Okay, great. But that also means the reference angle is 21.8. So where is tangent negative? Tangent's negative in the first and fourth quadrants. But we know, the second and fourth quadrants, we know that the angle can't be negative. So if it's going to be a negative slope, think about what that looks like. A negative slope is going to be downward. And so the angle of inclination should be a second quad angle. It should be an obtuse angle. It will be. So now basically what I'm trying to tell you, find me that angle. Find me the angle in the second quadrant with a reference angle of 21.8. So 180 minus 21.801, 158.199. Approximately. And that would be my answer. And then you can say, well, Mr. Saper, can't we just do 180 minus that, the absolute value of that? Yeah, of course you can. And you're going to get that angle there. And there you have it. All right, good one to end on.